With great pleasure, DCIV introduces the Morty Kit 1. This tutorial is made by the Wing Father and Thomas Anderson. And the main reason for this tutorial is to show how a wing is built. It's not required to buy the Morty Kit, you can source your own supplies as well. I really wanted to make a tutorial to show how a proper wing is built, and you can do it yourself. Well, we need to start with the build of the wing. We need tools and electronic supplies, and most important, glue, E6000. To laminate, we need a small iron, or a big iron if you don't have one. We need a soldering iron to connect all the electronic components. We need a new knife to cut the foam. And it could also be needed for hot glue. A ruler is necessary to cut the foam. And the foam needs to be sanded with the grit 240 up to 400. You need a glove to work with the fiberglass parts. A servo tester is necessary to adjust the servos to the middle position before we mount them. Masking tape with a marker so the marker does not mark the foam. 3M90 to make the foam sticky so we can laminate the foam. Or we can use Orca cover. The laminate will not stick without glue on the foam. Next, we have the medium CA glue with activator. This is to glue the fiberglass spars in. Now we get to the E6000. This we use to glue the wings together and for putting over the spars after they glued in with the medium CA glue. We can also use it to glue in the verts. It reacts with the EPP foam and this makes it ideal to work with. We are not sponsored by E6000, but we do have a big share in them. It's a rubbery glue that works very fine with electronics and other components. The other tube of E6000 has a bigger nozzle to displace more glue. For electronics, we choose a Vista Polar kit for the FPV system, a TBS receiver. We have a small quad flight controller to install in the wing. There's also wing flight controllers. A GPS module for navigation and auto launch, very important, and the return to home. And wing ESC 40 amps that works best for a performance wing. And 2 times a 9-gram servos to connect to the Elevons. Wing kit. What's in the box? The pre-cut EPP foam, the vertical stabilizers or wing tips, a piece of channel plate to cut the electronics bay and a battery bay from it. These are the wings, pre-cut, they fit perfectly together. Laminate for the Elevons or Tailorons, but we call them Elevons in this one, and the wings. And the thin one is for the Elevons and the thick one is for the wings. First, we glue the wings together and then we cut out the motor mount, electronic bay and battery bay. Then we put in the spars. After this, we cut the Elevons to the desired size. We mount the Elevons on this side of the wing and they need to connect seamless. This means that we have to cut them and sand them to size. These parts are to mount to the motor and push rods and more 3D printed material. And of course, very important, a sticker of the Wing Father kit. Gluing the wings to wing. What we need is E6000 and some pins. Now we are going to glue the wing together. This is the first step of many. On the middle of the wing put a nice bead of E6000 glue. The E6000 reacts with the foam so they will be merged together. Rub the 2 ends together so the glue spreads evenly. Then we press them together on a straight table so that there is a seamless joint between the wings. Then when they are put together, use the pins to hold the wings in place. You can also use tape or anything that sticks really good on the foam. Now we need to dry for at least 6 hours. After drying, you want to make sure everything sticks properly together. The front of the stitch is more important than the back because we'll cut out the back. Make sure the front is very tight, fitting together. And what is the top and what is the bottom? The flush, the flat side is the bottom and the curved side is the top. So we're 6 hours later. It's properly glued and dried. Now we can start drawing out the cutouts. In this step we need a ruler, a marker and a motor mount for the size, a knife to cut out the compartments, a 3D printed marking tool, and properly mark the lines from the foam. And also we need is the LiPo to cut out for the size. We're going to use an 1100 mAh 6S LiPo, but whatever LiPo you need, try to cut it on size. From the back we measure 10 centimeters from a 2207 motor. We can play with that for the CG, not too much. But if you put it in the back, so less than 10 centimeters, we can mount a HD cam permanently, or more to the front, so 10 centimeters more for a lighter setup. Put the marking tool on the middle line, start drawing from there and draw the cut for the motor mount. The horizontal line is 2 times 9 centimeter, so the 5 or 6 inch prop will fit. The Elevon size will be 30 centimeters, so we measure this from both sides. Draw the line to the trailing edge. It needs to be accurate, so measure multiple times to get it right. The electronics bay will put 2 centimeters away from the motor mount. Then we have 6 centimeters for the electronics bay. After this we draw out the outlining of the LiPo. And then we have to draw in the servos. About 3 centimeters to the side and 10 centimeters up. Then we cut out carefully what we have drawn. Don't cut it roughly, just cut it nice and smooth, layer by layer, and you fully cut it through eventually. This will make sure that you cut straight lines, but also not take off any chunks.
En je voelt vanzelf als je er doorheen zit. Ja, dan gaan we naar deze kant toe. Recht houden het mes. Netjes uitsnijden.
When we have cut everything out, we're ready to put the motor mount in. The motor mount will be placed in the middle of the foam. Just measure it and cut it out. If the motor mount does not fit, first gently cut it out and try again. It should fit without any force. Fixing the spars. They're not called ribs, but spars. Because rib are to support extra things like a fuel tank and to maintain the aerodynamics, but ribs are the main integrity of the wing. So what do we need? We need a knife, a ruler, CA glue with activator, E6000 and the fiberglass spars. On the top of the wing we measure 2 cm from the leading edge over the length of the wing. In the middle between the motor mount and electronics bay we put another spar. Then cut out the lines 3 to 5 mm in the foam so the spar later fits in nicely. Take your gloves because glass fiber splinters are not nice. The first spar that goes in the spar between the motor mount and the electronics bay. The spars needs to be locked, so leave a small overlapping to the leading edge spars. You can push it with the knife blade extended and with just to push it softly in. On the back we put the leading edge spars 4 cm to the back so the wing keeps its integrity. And now we put the spars into the same way. As option we can leave them overnight so they set really into place. Put the wing flat on the table and push so it will be straight, looking over the leading edge so this is nice and straight. If it's not straight, and bend them a little bit. Now the spars are not glued in yet. So when everything is straight, put in a medium CA glue on the spars, leave it on for a minute. Look again if it's all straight. If you're happy with the result, spray the activator on the spars and wait for a minute to set in. After this you can fill up the spars with E6000. It makes it more crash resistant. Do the same thing for the bottom side. We can glue the motor mount in with E6000 and let it dry for about 6 hours. Do not put glue in the end, only in the beginnings. If necessary, put clamps to hold it in place or use something heavy. Make sure the motor mount is nice and flush against the foam. Cutting on the tray and lid. What are we needing? We need a knife, a marker and a channel plating. You can also use a different material, like PLA print or any other plastic, important that it should be light and durable. We're going to make the electronic bay and the battery bay from the channel plate. And also the electronic bay is going to have the same lid made from the same material. We need to measure it. We need a small edge to glue it in. Cut it out to shape, then cut the foam in 3 mm down to put the bottom in. It should just pop out. Glue the other trays in. For the lid of the electronic bay, we need a hinge. So we only cut out the side of the channel plate and cut out the ventilation gap. Lamination. What do we need? Knife, scissors, sanding paper, 3M90 glue, an iron, and lamination foil. Important with the lamination foil, the glossy side is up and the matte side is down. This is the one we're gonna put down on the wing. We're going to sand the wing softly so there's no glue lumps and a nice smooth surface. When everything is nice and smooth, we're going to get the 3M spray and spray the glue on. Best to do this outside. First we're going to do the bottom, laminate the bottom, and then we're going to do the top. We start by laminating the bottom of the wings. Make the iron hot, but not too hot. Put the sticky part to the wing and keep the smooth side up. Make sure it sticks in all places. Take your time to make it nice and smooth. Leave a small space to wrap it over onto the top side, on the leading edge and trailing edge. Same for the other side. Heavy excess amounts of lamination you can cut off, but make sure to leave a little bit so you can make overlapping edges. If you have an unstraight surface when there's a little bubble or whatsoever, use the heating iron to make it flat and leave it a little bit on the surface to see if it will melt down. Make sure to not keep it on too long because you don't want to get burning places, obviously. So, lamination foil on lamination foil adheres pretty easy. Unlike on the PPE, you don't have to treat it, just spray it a little bit and it will perfectly laminate together. Then we're gonna cut everything to size. And as last, we're gonna cut the servo holes. I'm gonna draw the ailerons. Elevons in this case. What do we need? E6000. We need iron, knife, laminate, the thin one, sanding paper on the block, ruler, marker, hinge paper or plastic hinge. Draw the ailerons on size and saw and cut them to length. Sand them to match the thickness, then they have to connect seamlessly to the foam. Now they are to size and the right thickness. So look and double check the ailerons that they connect seamlessly. I used hinge paper in the video, but you can also choose another way to connect them. I like it this way because it's very easy and it gives good results. I made 3 per slide in this example, but 2 per side will do. Maybe one of the hardest part of making the whole wing is making the cuts into the ailerons and the elevons and connecting the hinge paper with the wing. So what you want to do is you want to take your new fresh sharp knife and make a small incision in the same width as your paper. If it doesn't fit the first time, try to make it a little bit bigger. You want to make sure it's nice and flush, not too loose or too tight that you have to force it in. It has to go in pretty easy, nice and flush. As you can see now, it will stick properly. So this one is done. You want to repeat it 6 more times. I laminated the ailerons to protect them and make them smooth. Start on the bottom and make an overlap to the top. Nice. And make it smooth. After lamination, you have to cut open the slits again and put the hinges in, and this time we can use glue to fortify it. Then we made small marks on the trailing edge because we're going to cut the trailing edge now. Same way as you put the hinges into the elevons, you make a small incision in the trailing edge fitting your hinge paper. apply some E6000 and make sure they're slid in properly. Now we put some tape over the ailerons, but it will need to move easy to the top and bottom position. This tape prevents the air from escaping between the ailerons. Move the ailerons down so you can see that there's not too much force needed. If the gap is too small, the force to push it down will be too high. Placing the servos and testing. What do we need? E6000. Now we're going to put in the servos. In this example, we place the servos vertical. In a vertical way, I find it easier to put in and to cut in. Put them both in the same way and the same distance from the aileron. Put the control horns on the servo on the ailerons. You have to put the servos in the middle. This is done with a servo tester. Find the middle position or the neutral position for the servos and then attach the control horns perpendicular to the ailerons. Now we're going to install the control horn and push rods to the aileron. Connect the push rods with the M3 screws. Then you want to align it with your servo. Use the M2 screws to make it stuck. And now we're going to punch a hole in the control horn. You can use a 1.5mm drill. And we heated just a very small screwdriver and poke it through. Make sure it's not too big, also not too small, then it cannot move properly, but too big, it gets too much wiggle. Nice and snug. Then we're going to pull out the servo tester and see if they move freely. If they don't move freely enough, make the hole a little bit bigger. And if you blew it, you have to replace the control horn with a new one. Camera bay and electronics. Now we're going to put in the electronics into the wing. In this case we have an air unit, a polar camera that will be put in the nose, a nice drone flight controller, an ESC 40M for the motor, a GPS and a TPS crossfire receiver. Cut the nose in the frame, take your time for it and make it nice and tight. When the electronics are tested and the camera is in, glue the nose in place. Now we have put in all the electronics. Finalizing. We're gonna glue on the verts. And now the most important, we put the sticker on. The electronics are in, the monitor is mounted with a 2-inch biprop. Download the latest iNav throughout the link provided. Unzip the file and install it. And then important, to flash your flight controller. Make sure the latest firmware is there. Select the firmware updater, auto-select it. And if it doesn't go to DFU mode, use a program like Impulse RC Driver Fixer to fix it and to put it in DFU mode manually. But here, everything went straightforward. So, it's erased, it's flashing now, and now it's done flashing, so we can start programming the flight controller. First, you want to select what type of plane it is. We select an airplane without a tail, aka a wing or a delta. And if you mount the flight controller in the correct way, then everything works as it should. And if not, go to the alignment tool. So we're going to the next step, calibration. We're going to select calibrate accelerometer. And then we're going to perform the tasks, basically positions which are required. Just follow the pictures and read. First position is going to be flat, quite obvious one. The other one upside down, and just follow the pattern until it's completely calibrated. Now it's done calibrating. Next step, mixer. So we're now at the mixer tab and we're gonna do a mixer preset. We load and apply. We'll restart the drone. Yes, save and boot. Let's go. We will be coming back here later, but for now we're done. We're gonna go to the next step, the motor outputs, or at least the outputs, because the motor is not by default enabled. We're gonna enable the motor. So enabling the outputs, you can also select a different motor protocol like D-Shot, but the default setting is just fine for wings. Next one, ports. Our configuration has the receiver on the UART1, so that's the serial RX. The DCIV TX is the second one, so we use MSP DisplayPort, and then we have selected the GPS configuration. We're actually only going to change one. That's the permanently enable auto launch. That's actually the only option you're going to select on, and the rest should be already standard there. The next step is going to be the failsafe. And here we enable the return to home when failsafe, so it comes back when it failsafes. Next step going to be advanced tuning. Well, we're not going to do much, but most important one, fixed wing auto launch settings. So these are just the settings I prefer to use. Just making sure that the motor is spinning enough, but not too hard when I'm starting it. I'm increasing a little bit the angle of the launch rate, but this completely differs what kind of hardware you have. If you have similar hardware as we put in, 6S, 5-inch prop, on the Morty kit, you can apply these settings and see if it works for you. If not, make a little adjustment. The same as the return to home settings. We cannot give exact advice because it really depends on the environment you're flying in. Okay, now the receiver tab. Well, put in the right receiver mode. We have crossfire, so we selected the crossfire protocol, and you want to make sure that your channels are correctly mapped. Roll is roll, pitch is pitch. If it doesn't, then you have to replay with the channel mapping, put different letters, make sure they match the same order as your controller. If that is set, we're going to go to the next step. You're going to set up the modes. And this is how Wingfather sets up his build. The only mode you really need is the arming mode. If you have this not configured, the drone won't arm. The auto launch is permanently enabled, so there's no switch for that. You arm, you throttle up, and then your auto launch will go on. But there's a few buttons which marks advice. Well, one of them is add the return to home button. You can add a beeper. You can add auto trim on a button instead of having auto trim automatically performed. So you do it on a switch. Another one is you can put your air unit on a switch so it doesn't start cooking while it's searching for GPS. But if you have a good GPS, then it shouldn't be a problem. So the most important one is arming, and the second one is return to home. Because if anything happens, you can press on the return to home button and it goes in a cruising mode back. That's also good for basically if you want to scratch your nose or just want to reposition yourself. And the other modes, find out your own way. So we're going to go to the next step, GPS. Every region has its settings, but if you come from Europe, you can just use these settings, Galileo, U-Blocks. And if you don't have a GPS signal, there could be two problems, or there could be many problems, but two main ones. The TX and RX are swapped, or the protocol is not selected correctly in the ports tab. So if at the setup your drone was all weird, this is where you can set it correctly. The flight controller is facing backwards, so we had to add 180 degrees to the yaw, and that made it correctly. So if we go to the setup, you can see it's moving correctly. And if it moves correctly, we can go to the next step. We're going to skip mission control. We're going to go to the OSD. Very important, because you need information. More information you have, the richer you are. To begin with, if you have a Vista, then we got to select the Betaflight HD compatible. This video format is required because DJI doesn't have their own. There's many information you can put on, but there's a few required. Like, for example, the home position on aiming screen is quite nice. The fly mode is handy if you use several modes. Important is the system messages. Another one is your distance or your position. It really differs on how you're flying and whatever information you want to get. But the home position is quite important because you might lose it And for example, you can add an horizontal bar if you fly in different types of weather or above the clouds, which you're not allowed, but you can. And of course, the amount of satellites, because it's quite important how many satellites, and if it takes too long, then you might want to reposition yourself, or maybe you're next to a fence or whatsoever. Any other information, do whatever you would like. We're gonna go to the last step, and as promised, we would come back at the mixer. We want to make sure the input matches the movement on the Elevons. First, take off your prop, then turn on your controller and plug in your wing with the LiPo. We're going to make sure the inputs are correctly. First, you want to check the pitch. If the pitch doesn't match, so if you press towards you, it should go up, and when you push them away, they should go down. If it's other way around, then mix those values in the pitch. And same, you're gonna check your roll. For example, if you roll to the right, the flap must go up, and when you roll to the left, the same flap must go down, and vice versa on the left side. So you got your wing set up now. If you have any questions, always you can ask them in the comments. We come right back at you. But let's try out the wing now. So the finished product is the wing. I'm just gonna run through the electronics. This is not necessarily an advice, but this is just what we put through it. So we picked a flight controller, just a drone flight controller. So the Vista unit would give easy OSD. The GPS would be easy command. Of course, you can take a fixed wing or a different flight controller just for wings, but this was more convenient and we had it laying around. So the flight controller is powering the VTX and the RX. We choose a Nano from the TBS, and obviously some GPS. And then lastly, you have the you have the motors are being powered by a back. Sorry, the servos are being powered through a back, through one of the motor wires. And you have the ESC, single ESC, it's 40 amp, and we use a 6S 1750 motor, and it's built-in LEDs, so it gives some cool thing to chase. And like I said, we use a Vista unit with a polar cam, because we can also fly in the nighttime. Let's maiden this puppy.
Millo. Geen dank, hè? Doe de rekening. Ja, nee? 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 Dan doet hij nog niks. Nee. Armen. En dan gas. Oké, gas. Gassen.
Naar beneden, dan ga ik extra gas erbij.
Niet zeker, stikken. Niet zeker, stikken. Ik zie die linkerduim heten bewegen hoor, voor die Jan. Ik heb helemaal geen Jan. Kom even voorbij, hey, kom even een flyby. Oh nee, wacht, het is je eerste vlucht, rustig aan.
Laat me even rustig doen.
Hey!
Ja, helaas, ik kan niet meer volgen.